Okay, sigma notation part 4, the next example. So for this question, they ask, find the value of n. Okay, so as we can see, there's nothing here, so let's start. Okay, my question 1 is, what is this? So according to this formula over here, is it an arithmetic or a geometric series? And there's an exponent, so it gives it away as a geometric. Fantastic. So we have this one down. Step 2 would be expand. Okay. Again, I need my first term, a, and that I go read from here. Okay. So a we have as 3. Okay. With geometric, we have a ratio, which is r, and my ratio would be 2. Getting it from here. So again, this is the geometric sequence formula. So you will be able to read mostly, if that's not something they ask, you will read it from there. So now I go expand. So my first term was 3, and plus, because we're busy with series, so 3 times 2 is 6. Okay, plus 6 times 2 is 12. Plus 12 times 2 is 24. Okay, now, do I have the final amount of terms that we're going to have in this series? No, because that's what they're asking. They're asking n. Okay, so this continues. And because we don't have a final one, we're going to say the last term is plus 3. So this is this formula, n minus 1. We will end our series like that. Okay, that's if you don't know the last term. Okay, now that we've expanded, our next question is the formula. So now, the question should be, is r bigger than 1? Or is r smaller than 1? Okay, now r is 2, so it would be this one. So the formula that we're going to use is Sn equals a times Rn negative 1 over r to the power of n. Oh, not to the power of n, sorry. R negative 1, just r negative 1. Okay. Now we go fill in what we have. Do we have Sn? Big question. Yes, they gave it here. So remember, this is the sum is equal to 381. So they gave us Sn. So 381 equals a we have as 3, r we have as 2 to the power of n negative 1. And again, the bottom r negative 1, so it would be 2 negative 1. Okay, so important side note is that over here, 2 negative 1 equals 1, so this will fall away because it's over 1. Okay, so that leaves us with 381 equals to 3 times 2 to the power of n negative 1. Now I need to get this 3 away. So basic principle, I'm going to divide by 3 on this side, and what I do on one side, I do on the other side. So when I divide by 3, I get 127 on the one side, and on the other side, I'm left with 2 to the power of n minus 1. So I want to get this alone. So I'm going to take negative 1 over, and when I take it over, it becomes positive. So 127 plus 1 is 128 equals 2n. Now the exponent bothers me a lot. So the one rule I know is if the bases are the same, the exponents are equal. So to get the bases the same, I'm going to say 2 to the power of 7 equals 2n. Now do you see the bases are the same? So I'm going to say 7 equals n. And that's what they wanted, the value of n. So yeah, that is a geometric sequence and series in sigma notation if they ask n. But again, you're going to follow the steps, and at the end, you should get whatever they ask you. So please make sure you check what they give you and that you understand what everything stands for.